Any clarification before we move to the calculation further? Any clarification? Right. So how many of you have already calculated the values? How many of you have already calculated the values? Last time we were discussing about an example in what you call factorial experiment. So that is based on the computer performance, which is given in the output in seconds, where we have two factors. One is, I will show you, these are the two factors. Yeah, I hope you can see here. These are the two factors, right? Can you all see the screen?
Yes, sir.
Two factors are the factors on one factor. Factor A is based on different multi-programming. Factor B based on the capacity of the computer. 30. You have maybe heard about this capacity, different computer capacity. So these are old type of questions. So that the capacity 32, 64, and 128. Almost these are capacity of some 20 years ago. Now the capacity is 2 GB, 3 GB. These are megabytes. All right. Now we are talking about capacity in 2 GB, 4 GB, 8 GB, and so on. Right. That is the difference. So now this is the question. Now we want to find out whether there is an interaction, whether some computer, some memory can handle different types of multi-programming. Whether we want to have, whether we can find any interaction in this, right? So based on that, how many of you have already done this part? How many of you have already completed? So I'm going to put up the ANOVA table. So, all right, ANOVA table. So this is, before ANOVA table, we want to develop the testing procedure. What is the first test? First component in the testing procedure? What is the component in the testing procedure? First component in the testing procedure. Anyone? Hypothesis testing, formulation of hypothesis testing. So my null hypothesis and the alternative hypothesis. Can you all hear me?
Yes, sir. We hear.
Okay, right. So null, what is the null hypothesis? Which is common to all the design. You have already done this. What is the null and alternative hypothesis? Anyone?
All the means are equal.
All the means are equal.
Which means mu1 is equal to mu2, mu3 equal.
Okay. Right. All the means are equal. At least one mean is
differs from each other.
Yeah, different from rest. This is we have done. This is for CRD, RCBD, no problem. Even for Latin square design, you have learned this. Now we are learning factorial experiment. We are talking about factorial experiment. Very factor over admit time factorial experiment. We are talking about factorial experiment. So here not like CRD, RCBD, LSD. If you combine this factorial experiment in either of this case, now we have several effects. Can you remember? We talked about in the last class few effects. What are the effects? We can categorize this effect into two major groups. Anyone?
Main effect.
Main effect.
Interaction effect.
Main effect and interaction effect. So these are the two groups basically. Now the testing can be done for the main effect separately. Testing done for the interaction separate. Could you remember last time, and also along with our example? Our example, the calculation example is how many factors are involved? How many factors are involved?
Two factors.
Two factors. I will just indicate the model. Right. So here, let's say I is the factor A, which is indicating what is factor A in our example. What is factor A in our example? That is about the program.
Program.
Or multi-programming. So how many programs are there? I can take a value 1, 2, 3, 4. Similarly, what is J?
Memory.
Memory. So J can take a value. How many values are possible in our example?
3.
1, 2, 3. 1, 2, 3 possible. 3 values are possible. Right. Now, these are the things.
2 factor.
Somebody's mic is working. මේ කවුදරි mic එක on කරලා වෙන දේවල් කරනවා mic එක off කරන්න. Right? So that here I is programming, J is the memory. So we know alpha 1 is possible, alpha 2 is possible, alpha 3 is possible, alpha 4 is possible. So this is the main effects of what? Main effect of what? Anyone?
Factor A.
Factor A here, main effect of program. Right? If you test this, that is the main effect of program. Now, similarly, beta, how many values are possible? Beta 1 is possible, beta 2 is possible, beta 3 is possible. So, if I test the betas, what I am going to test? It is the main effect of what? Memory. Right. In a normal experiment, this is the two testing that I have. But here we have a factorial. The third component is coming into play. What is that? Alpha, beta, 1, 1. Alpha, beta, 1, 2. Alpha, beta, 1, 3. Similarly, it goes up to, you can write the whole thing, the last one, alpha, beta. How many combinations are there? Anyone? How many combinations are there?
Random.
12.
Yes, 12. What is the last combination? Am I right?
4, 3. Yes.
Yeah, last combination is. Now we can test this also. So if we test how I can write interaction effect of programming and memory. Interaction effect of programming and memory. So you see, when we formulate our null and the alternative hypothesis, we'll have to aim on what test that we are going to perform, whether we are going to test this, whether we are going to test this, or whether we are going to test this, in this case, in this exam. Is it clear? Right. So here, not like easy for earlier case. Earlier case, only one we have in CRD, normal CRD, we have one set of treatment. So we will see whether there is a treatment effect, whether all the treatment means are same, or whether or at least one of the treatment mean is different. But here we cannot declare that. Why? We have two factors. So we can see whether factor A is effect, whether factor A is having any effect, or factor B is having any effect factor, or the combination of A, B is having effect. You see, this is one step. Normally, can you remember when I said at the beginning of the factorial experiment, what is the purpose of doing factorial experiment? What is the main purpose of doing factorial experiment? To investigate the interaction. Right, to investigate the interaction. That normally we want to first give the priority to investigate the interaction. Right? In case of interaction is not present, then we can go for the testing. So first, we'll have to test the interaction. In the absence of interaction, then go for testing main effects. Then go for testing main effects. Is it clear? So for example, in our case, we have three combination of effects, three effects. What are the main effects? We say programming, right? We say memory, and also we say the interaction between programming and memory. So we have three effects. So what is our prime job in factorial? In factorial, our prime job is to test the interaction first. Test the interaction first. Then, if there's absence of interaction, if there's an absence, or in other terms, if there's no interaction, then we can go for this testing the main effects. Right, we will see that when you do it using SAS. We will see that later. But here we do it manually, but using SAS, it is very easy. So that we can do it. Right, now I'm going to show you the pathway to test the interaction first. Right, we are going to test the interaction. Right, now in that pathway, now I am going to formulate your null and the alternative hypothesis. Tell me how we can formulate null and the alternative hypothesis. Anyone? How we can formulate null and the alternative hypothesis? Just give a brainstorm, no problem. I'm not going to blame anyone. Just give your ideas. What is your null hypothesis? What is your alternative hypothesis in this case, in this example? Anyone?
There is no any interaction.
Yeah, that we can say there's no interaction. Fine.
alternative, there is an interaction with
Okay.
effect of.
Okay, right. So basically, if I, yeah, that is correct. By word, what you said is correct. So we can test, as in this example, my null hypothesis may be alpha I. We can test alpha I, whether alpha I is equal to 0. Or my null hypothesis beta j is equal to 0. What about the third null hypothesis? Possible. We cannot test all at once, but we can test all individually. That is the third one, is the one that we are interested. Alpha beta ij is equal to 0. So this is the interaction effect, right? Interaction effect. So this is what I said at the early stage. We can test. You have done this before. You are looking at the effect of one treatment or one effect, right? Okay. So here, now we are going to look at to test the interaction. Right. Tanush Kumar, right? Told with the text form that the null hypothesis where there is no interaction present, the alternative hypothesis where the interaction is present. So I will write null as no interaction. Interaction between what? In our example?
Multiple programming and
yeah, programming and memory. Right. Alternative, there's an interaction between programming and memory. How we can write this in mathematical formulation, similar to earlier one, right? We can say alpha beta is equal 0. So this is how we alpha beta ij. You can, if you want, you can put ij. Ij is not necessary, but you can put it if you want. So that means all the combination effects are same. For example, this imply, what are the possible combination? We said already 1 1 is same as alpha beta 1 2 is same as alpha beta 1 3. So likewise, you can write it. How many combinations are there? Etina combinations combinations kiya tiyena?
12 company.
You can write it up to 12. But in general term, we write it like this, the effects. So this is what it is. Alternative, alpha beta right is not equal 0. So that means at least one combination is different from the rest of the combination. At least one combination is different from the, at least, because we cannot say maybe first combination may be different from the rest of the 11 combination, or second combination may be different from the rest of the combination. Right? So we can look at the in a different way. So we can say at least one combination effect or mean of at least one at least mean of one combination effect is different from rest, right? So that is our null and the alternative hypothesis. Anybody has problem in null and alternative? Anybody have problem in null and the alternative hypothesis? இப்பவும் அதோன்று இருக்காங்க படிங்க கிளாஸ் எனக்கு என்ன பிள்ளைங்க இல்லை. What is the everybody should know what is the formulation of null and the alternative hypothesis. Fine, right? The second step is test statistics. So for that we'll have to develop the ANOVA table. Right, now we are going to look at the ANOVA table. I'm going to put up the ANOVA table. Source of variance, degrees of freedom, sums of squares, mean square, F value. So these are the table information that we need to fill it up. All right. Now tell me, I will ask question. Give me a break. I will ask a question from everyone. Right. Yashani Samudika. Class again now?
Yes, sir.
Kianna Balamu, I mean, tell what are the possible source of variance that we can list. Tell me what are the source of variance in our example. In our example, we have started calculating our example. What are the source of variance? Tell me.
Alpha.
Pardon?
Alpha.
Alpha. Oh. Alpha, what are the source of variance? How I can fill this? What are the components coming here? What are the components?
Treatment.
Huh? Oh,
treatment.
Yeah. Here we don't call it as treatment, no. Right? Okay, fine. First one is, as you said, we can put treatment because it is. Yes. Okay, fine. Okay, go ahead. Treatment, which combine the whole thing. Okay, fine. What is next?
Alpha beta.
Alpha beta has some name now in our example. What is alpha? We have given up to now. I was talking about what is alpha.
A.
Oh, A. What is A?
Programming.
You'll have to tell like this. A, B, C, Natannipa. So you'll have to tell program. So first effect, factor A, because I didn't ask the question as factor A. For example, for factor A, program. So my first effect is program. Within the bracket, you can put A, no problem. Right. What is next? Continue.
Memory.
Memory. Okay. Then we can put that as a B. What is third one? Interaction. What is that?
Program and memory.
Okay. Interaction, program into memory.
And
A, B. We can write that as a B. Fine, good. Then what is next?
error.
Error, because here we are talking about CRD. Then the last one?
Total.
Total, good. Right. Now I will catch another person. Subhangi Pusparaja. Are you there?
Yes, sir.
Tell me, in our example, what is the degrees of freedom for treatment? I need the
11, sir.
11. How did you get that value?
A factor into B. A into B minus 1.
A into B minus
1.
Very good. So 11. So everybody should know how we get this value. Look at the formula. I gave the formula. So look at the formula. Right. Subhangi, tell me what is the degrees of freedom for program or programming?
Programming A minus 1, that is 3.
Good. Then memory?
B minus 1, and that is 2.
Okay. Then AB?
Interaction A into B, that's 6.
You see here, you can cross check. If you add these three values, it should be equal to this. Otherwise, something wrong. Clear? Right. What is next? Total degrees of freedom. What is the total degrees of freedom in our example?
23.
Yeah, 24 minus, that means A into B into R, which is 24 minus 1, 23. Fine. So that what is the error degrees of freedom?
12.
So 23 minus 11, right? That is 12. Don't remove double, don't subtract twice, only once, because this is same as this. Right. Okay, good. Subhangi, good. Now we come to the most important calculation, that is our sums of square. Anyone, did you calculate the sums of square yesterday? I mean, not yesterday, day before yesterday, I gave you the clue how to calculate the sums of square. Did anybody calculate the sums of square?
Yes, sir.
Yeah, what is the answer? For treatment, let me tell me the sums of square for programming. Value?
3.3741.
Very good. I will put it in a right. What is the value?
3.3714.
Okay. So you calculated very accurately, yeah? Good. Okay. Yes. For the second one.
Memory 0.5152.
0.51.
152.
Okay. So did you do it manually or?
Yes, sir.
Did you do it manually? Good. Right. Because you are giving answers which is taken by computer. So that means the manual calculation is maybe slightly different. Right, good. What is AB, Samsuska?
0.4317.
So if you add these three Samsuska, it should be equal to treatment Samsuska. So what is the treatment Samsuska then? Add all the value and tell me. Anyone?
4.3183.
Just a second. What is the value? 4.3183.
3183.
Right. 4.3183. Then what is the total Samsuska?
4.3476.
Very good. So what is the error Samsuska? Anyone? Error means?
0.0.
Yeah, total minus the rest. Or treatment Samsuska. Yes,
0.0293.
Right. Okay, good. So it's right. This gives the value. Anybody getting a different value? Anybody getting a different value? Tanush Kumar,
No, sir, same value.
same value. Where are the other? Kirija, one.
Yes, sir.
Yeah. Are you getting the similar value or different value?
I told these values.
You are the value. You are the one. Okay. Let's say Subangi.
Yes, sir.
Yeah.
Same.
Are you getting the same value?
Yes, sir.
Okay. Right. Now I want to cross check. So everybody has. So do you have any problem in calculation? Anyone? You can speak out now. Peony.
Yes, sir.
Yeah. Do you have any problem in calculation? Did you get the same value?
Yes,
Or
no problem.
you didn't get same value or different value?
Same values.
Same value, right. So who else? Can you all hear me? I just lost. Can you all hear me?
Yes.
Right. Okay. So hope everybody has. This is the time that you'll have to ask if you have a problem in calculation. Ask me so that I can explain. Arosha?
Yes, sir.
Yeah. හොඳටම තේරුණාද?
Oh, sir.
ඔව් ප්‍රශ්නයක් නැද්ද?
Nice.
Right. Good. නෙලු?
Yes, sir.
ඔයා දැන් මේක හදාගන්න පුළුවන්ද ඔයාට?
Oh, no, sir.
පොඩ්ඩක් අනිත් කට්ටියෙන් අහගෙන පොඩ්ඩක් හදාගන්න. Right. Maybe
Sir. Thank
right.
you.
Okay. Sahana?
Yes, sir.
Yeah. Would you able to calculate? If I put a example similar to that in the exam, would you able to do it easily?
Yes, sir.
All right, good. So I hope everybody can now calculate the values, right? Easily. Everybody knows, right? So that we have the sum square. We can calculate the mean square only for few items. So we need the mean square for programming, mean square for memory, mean square for programming and memory interaction, and mean square for error. Can somebody give the answers for those? Mean squares for each of these. A, what is the mean square? Mean square is actually sums of square divided by degrees of freedom. What is the mean square?
1.1238.
Right. What is the mean square for B?
0.2576.
Right. What is the mean square for AB?
0.07195.
195. Okay, I will take it as 20. Huh? Then error degrees. Sorry, error mean square.
0.0024.
0.00, very low, right? 0.0024. Fine. Now, first we'll have to, as I said, we'll have to test the interaction. So what is the interaction component? We know the interaction component is this one. So we'll have to calculate the F value. The calculation of F value is based on the interaction effect of AB, or in other term, interaction mean square divided by error mean square. Interaction mean square divided by error mean square. That is the calculated value that we use to test the interaction, whether there is interaction. So tell me, what is the value? So this is the value. The value is 0.0720 divided by 0.002. Can somebody get the value? What is the calculated value?
29.58.
58. So now this is the interaction. Huh? Similarly, you can calculate this for the safe side. If there is no interaction, we can test A and B separately, or programming and memory separately. But at this stage, it is not necessary, because first we want to see whether there is an interaction. Right. Now we are going to take this away, 29.58. So my F calculated value is 29.58. Now, if you are doing it manually, how to look at the value of compared to? So this is our test statistics. This is the test statistics. So here in ANOVA, I mean in this design, our calculated value, we can take it this as closer to 30. That is also possible. Doesn't matter, right? So test statistics, right, is actually you extract it from ANOVA table, the calculated ANOVA table, right? Similar to our t-test and so. So after taking, now we want to have a table value, F table value. Can somebody tell me what are the information do we need to look at the F table value?
Degrees of freedom.
Yeah, degrees of freedom of what?
AB. Interaction.
Once again, degrees of freedom of what? Degrees of freedom of numerator, which is here interaction. Degrees of freedom of error. So tell me, what are the degrees of freedom for this already in the table? What is the interaction degrees of freedom?
6.
6. You have to open up your mouth. What is the error degrees of freedom from the table? It is already there in the ANOVA table. Yes? 12. Right. These are the information that we have. Then we'll have to look at, we need the alpha also. What is the alpha? As usual, 0.05. Right. Now we will go back to the table. I have the table, I think, where it is. So this is the table. Can you all see the table?
Yes, sir.
Right. Okay. So we go for the numerator degrees of freedom. Numerator degrees of freedom is 6. Denominator degrees of freedom is 11. 11 or 12? 12. Huh? Right. Now, here we have first digit is belongs to alpha value 0.05. Second digit is belongs to 0.01. So that we'll have to look at for the first digit. What is the value? Anyone? 3. Right? The value 3. Right. We'll go back to our ANOVA table. So my table value here, I said it is 3. My calculated value is there, table. If you show it graphically, you will understand much better. So this is my critical area. So this is the non-rejecting region area. This is non-rejecting region area. So my critical value from the table is 3. What can you say about your calculated value? Where this calculated value falls? Is it falling in? Yeah, this is. Yeah, this is falling in rejecting region. So in other terms, that is why we could say our calculated value is great. If our calculated value is greater than the table value, we reject our null hypothesis. So in this case also, we have 29.58 or something, which is much higher than the table value, which is 3, so that we could reject our null hypothesis. Go back and see what is our null hypothesis. We said there's no interaction effect. Null hypothesis. Now, my decision is we reject our null hypothesis or we accept our alternative hypothesis. So what is my conclusion now? Anyone? There is a interaction between what? There's an interaction between what? We'll have to write in a text form.
Memory and program.
Yeah, programming or multi-programming and memory. Multi-programming and memory. There's an interaction between multi-programming and memory. So in other terms, at least one of the combination mean is different from the rest of the combinations mean. At least one of the combination mean is different from the rest of the combination mean. So that, what is next step? Anyone? If there's an effect, If there's an effect, what is the next step? What is the next step? Next step. What is the next step? Sajid. Sajid. Yes, sir. Yeah, Sajid කියන්න බා. ඊළඟ පියවර මොනවාද? That is true for ANOVA also. If ANOVA, in the ANOVA table, if the treatment are significant, what is the next step? Tuaraka?
Yes, sir.
Yeah, what is the next step? அடுத்த step என்ன? Not only here, but also in CRD, RCBD, you found treatments are significant. What to be done next?
Confidence interval.
Not really. I will explain in simple form. Let's say in CRD, forget about this factorial. I'm just CRD. I have 4 treatments in an experiment. Now I say reject from the results, reject our null hypothesis, accept our alternative. What is my null and the alternative? Anish Kumar?
Yes, sir.
Yeah, what is our null and the alternative hypothesis in general? In normal CRD, you already told at the beginning. Not factorial, I'm talking about just CRD design with treatments.
There is a
Treatment means are same, isn't it?
Yeah.
Null hypothesis. Alternative?
at least one mean is different from rest.
Right. Now you are accepting your alternative. So my conclusion is at least one mean is different from the rest.
So do we want to find out which treatment is different?
What is that? Yes. So now we said at least one mean is different from the rest. That is fine. Now we want to find out what is the next step. We want to find out which treatment is different from which one. For that, what is the procedure that we carry out? Because we don't know which treatment is different from which one. We have only 4 treatments. We say at least one treatment is different. At least there may be 2 treatments mean different from the rest, or 3 treatments different from the rest, or all the treatments might different from each other. What is the next step?
We want to test the treatment.
How we call it as? One more topic to covered by your madam. What is the topic? The
Mean
last one.
separation.
Mean separation. So mean separation. So that is the step. Mean separation is the next procedure for any. If there's a significant effect, if we reject our null hypothesis, if we accept our alternative hypothesis, maybe in CRD, maybe in RCBD, maybe in Latin square, or maybe in factorial experiments in any of those designs. If those are significant, if we are rejecting our null hypothesis, then the next step is we want to go for a mean separation procedure. Because we want to find out who is showing the difference with the rest of the mean. Showing the difference mean that particular treatment mean could be having lower value, or it can have higher value than the rest. We don't know. So that is what we said, difference. All right. Maybe higher or lower, that we don't know. But we want to find out. That is called as mean separation. Right? Now, because Madam will cover that under the mean separation. Tanuskol படிச்சிட்டீங்களா அது இன்னும் இனிதானா next week
இல்ல
right now I'm asking question from everyone. I send the message through your best friend from 4th to 8th of next week, October from 2 sessions from 8 to 10 a.m. and 3 to 5 p.m. Reserve these two time slot on every day from Monday to Friday. What I'm going to do is from 8 to 10, I will get the design course that is based on theory class. Then from 3 to 5, we are going to practice with practical, the other course. How do you call biostatistics, right? The other course, you call it as biostatistics. Am I right?
Yes, sir. Yes.
Right. Now I would like to ask, you have several specialization, I know. Anybody having problem with this time slot? You have to speak frankly. Argam in the time ledum பிரச்சனை இருக்கா உங்களோட டிபார்ட்மெண்டோட பாயிண்ட் சைட் பண்ணதா எதுவும் பிரச்சனைகள் இருக்கா කාටරි මොනවාරි ප්‍රශ්නයක් තියෙනවද මේ ටයිම් ස්ලොට් එක ටයිම් වෙලාවත් එක්ක ඔයගොල්ලන්ට ස්පෙෂලායිසේෂන් එහෙම තියෙනවා Tanis Kumar நீங்க தான் ஆன்சர் பண்ணணும் எல்லாரும் டம்மியா இருக்கீங்க
No, sir. You can take your own time.
Right. So, in the time இதான் ஃபிக்ஸ் பண்ணியே வைங்க ஒருத்தருக்கும் கொடுக்காது
sir. சொல்லி அது அன்றைக்கே சொல்லிட்டேன் சார் எல்லாரும் ஓகே என்னடினா மவியல
ரைட் ஏனென்றால் இப்ப காலமேல தியரி எடுத்துட்டு பின்னத்துல பிராக்டிகல் செய்யும் ரைட் so in practical I think I heard from Mr. Vanugopan that almost all of you have this SAS, access to SAS. I'm going to cover only the SAS. இருக்குதானே everyone? How many of you don't have SAS? Raise your hand. How many of you have problem with SAS? Yeah, I can see some raised hands. 10, 11. Good afternoon. Arosha to ප්‍රශ්නද SAS නැද්ද?
Yes sir. නෑ download කරාස යනකොට මේ වැඩ කරන්න බෑ සර් ඒකේ මොකක්ද මේ error එකක් එනවා.
පොඩ්ඩක් වර්ණ සර්ට කතා කරලා හරි ගස්සනවද? ඔයගොල්ලෝ බැච් මේ තනුසන් நாங்கள் SAS வேலை செய்யறோம்னா எல்லாத்தையும் வேலை செய்யணும் மறுபடியும் ஏதோ எரர் ஒன்று வருதுதான் ஒருக்கா வேணும் சார்கிட்ட சொல்லி எல்லாருக்கும் ஒருக்கா திருப்பி ஒருக்கா இன்ஸ்டால் பண்ணி வைக்கிறீங்களே
சார் நான் சொல்றேன்
எங்களுக்கு திங்கட்கிழமை பின்ன இருந்தா நான் செய்ய போறேன் அது மட்டும் உங்களுக்கு டைம் இருக்குது தானே இன்னைக்கு
வாரக்கிழமை
வார திங்கட்கிழமை
சார்
So before that, if you can fix the problem, that is better. Bhagya, what is your problem? Do you have the SAS or do you have other problem? Now, people who don't have laptops or desktop, raise your hands. Others, you can install. No, you can talk to Vanugopan and install talk through our batch rep and install it. Bhagya, what is the question?
So I couldn't install it.
ඒක install කරගන්න බයනෝසට කතා කරලා. ඒක install අදම ඒකට යොමු වෙන්න install කරගන්න ඉක්මනට.
Okay, sir.
මං ආන්නේ I'm asking who doesn't have really a gadget to install it. Because installation is not a problem. You'll have to give the email. Now you'll have to register. Always you'll have to work online. Right? So I will take this SAS by next Monday evening, so that by that time you can get it. Please attend itself. Right? Tanush Kumar indake paathu oruka kalichu overthata pirachane vennandu paathu thingakkalama. Otherwise you will be in trouble. Even you can, if you cannot just type as you like in the exam, because sometimes, because SAS is very sensitive. If you don't add one character, it doesn't run the program. So it is more sensitive. So that when I do, you also have to do parallelly. So that is why. So everybody, I think almost everybody has devices, because you are in the final year now. So hopefully everybody has devices, I think, so that you can install it, right? So anyhow, it is needed only on Monday evening, not today. Monday evening, I will start SAS. Right. Now, as I said, in this example, interaction effect is present. Interaction effect is present. Therefore, no point of going to test whether the other main effects like programming and the other one is memory. To test programming is factor A, memory is factor B. There's no need of testing that. Right? Okay. Right. Any questions? Right. Now, tell me, any questions? Now tell me, if you have three factors. Oh, I will talk about in an early example, 2-factor factorial in CR. So that is what we have done in previously. Now 2-factor factorial in RCB. What is the difference? Tell me, what is the difference? What is the difference? Write down the model. Anyone? Same thing. Here we have additional one component, mu plus alpha I plus beta j plus gamma k. Oh, before that, alpha beta ij plus gamma k plus the error term ij k. So this is the difference. Can you tell me what is additional information here compared to the earlier model? What is the additional information here compared to earlier? Anyone? Here we have one more component added.
With gamma k.
Yeah, this is, the rest is same. You can explain. Rest is same. Right? This is also same. But this is different. Right? So here we can say, anyone? Yijk. How we can express this? Anyone? Here, what is coming here? Block is coming. So that we could say Yijk mean it is the observed value of ith factor A, jth factor B, and kth block, in kth block. Earlier we said in kth replicate. Now, instead of replicate, we say kth block. That is the only difference. Write down. Observe value in observe value of ith factor A, jth factor B, and in kth block. So only difference is that. Then mu is grand mean. Alpha I is the ith factor A effect. Beta j mean jth factor B effect. Alpha ij, alpha beta ij is the interaction of ith factor A and jth factor B. And gamma k is given as the kth block effect. Here we don't call it as replicate because indirectly block is functioning as replicate. So that it is kth block effect. Okay. Any questions? So this is the first difference. Any questions? If you have questions, you should ask now. Any questions? Tanush Kumar, what class like the Kamsat Pradhani is not there. She there?
Yes, sir. I am here, sir.
Ah, you are there, right? Good. Last time I used to speak to you. You are the best rep, right? Last time. Am I right? That's representative. Am I right?
Yes, sir.
Huh?
Yes, sir.
Yeah. Because I just recall. Yeah. Now, source of variance. You see, as I pointed out last time, when you look at your ANOVA table, these are the components represented in the ANOVA table. You see, these are the components. So, by looking at this component, how many components are there? 1, 2, 3, 4, 5. All right, 5 components are there in addition to the total. So now someone, can you tell me what are the possible source of variance? What are the possible source of variance? Anyone? Source of variance? Yeah. We can say treatment. That is including everything. So here, 2 factor, factorial in RCB. So factor A, factor B, AB interaction, and block. So this is one, this is another one, error and total. So you see, only this is addition to the CR, right? If I give the notations already there, I can just show you the notations. Just a second. This CRD, yes. No, all are CRD, RCBD not there, so that I can write down. That is given only for CRD. So I will go for RCBD. So I will get some space because not enough space. Give me a couple of seconds. I will go one by one, because depend on the space only. I will go treatment. Treatment, we say factor A, factor B, and AB. First, we will look at these three. So the treatment AB minus 1, it is already there, right? The factor A, degrees of freedom, A minus 1, factor B, B minus 1, AB is A minus 1, B minus 1, right? Will take some more space, that is why. All right. Right, that is A minus 1, B minus, A minus 1 into B minus 1. Then we have block, error, and total. So total degrees of freedom is AB R minus 1. Same thing. R is block, right? Then AB minus 1 into R minus 1. R means number of blocks, right? And here it is R minus 1. You can have the formula like RCB, right? So this is the degrees of freedom, where you can write this. I is from 1 to 8. J is from 1 to B. K is from 1 to R. So this is factor A. This is factor B. And this is block. In this case, it is block. Right? Factor A, factor B, and block. Right? Coming back to sum square. Sum square is same kind of calculation. Yesterday we did. Summation Yij dot square divided by R minus correction factor. We know the correction factor is given as y dot square divided by ABR is given as correction factor C. So I will put it here as C always, right? That is always same. The second one, summation y dot j, I dot two dots square divided by BR minus C. That is for A, right? For B, summation y dot j dot square divided by AR minus C. Same thing. The third one, or AB, it is the summation of y dot R square. Sorry. Yes.
So Ij.
Yes. Because summation, it is like summation Yij dot square divided by R minus C minus sum square of A minus sum square of B. Right? Then we have additional information. This is the only difference. The rest is same. The additional information that is about block effect, summation dot k square divided by AB minus C. That is the additional document that we are getting, block effect. The rest is same as earlier one. So the total is summation yi j k square minus C. So here, error is total minus the rest. Rest mean block sums are square and treatment sums are square. Right? So actually here the treatment sums are square is the partition of, right? So this is equal to this, this, and this. Right? This is equal to this, this, and this. So that is the difference in the ANOVA table. So you can do it in a simple form. Right? So I'll give a homework. This is a homework, right? Right? So here, this is, sorry. This is a homework, huh? B1, B2, B3. This is block 1, block 2, block 3. This is V1, S1, V1, S2, V2, S1, V2, S2. So V is the one factor variety. The S means spacing, variety and spacing. So we have some value. So already it is given for the combination. So this is actually 2-factorial in RCBD. My question, find the main effects and interaction. So here I'm asking main effects and interaction, all. We'll have to do it as separately, right? Construct profile map. Right. So I have just given 3 things. Find the main effects and interactions. Second one is construct profile map. The third one, prepare ANOVA, another ANOVA, second ANOVA, considering as a single factor experiment. Did you all understand the question? Next week I will ask the answers. That time, don't say I didn't understand the question properly here. Huh? Normally that is what people do. But a question තේරුන්නේ எனக்கு கேள்வி வடிவா விளங்க இல்ல sir. That is not a good answer. Right? கேள்வி விளங்கிட்டதோ? ප්‍රශ්නේ හොඳටම තේරුණාද? Huh?
Sir, last question, can you explain?
Last question. Consider this as a single factor experiment. That means, here how many factors are there?
2 factors.
2 factors. Last question is consider everything as 1 factor, so that this one has treatment 1, this one has treatment 2, this one has treatment 3, and this one has treatment 4. Because it is a single factor, isn't it? Without considering this, the last question. It's like T1, T2, T3, T4. So the ANOVA setup is different, isn't it? No main effects, no interaction. Only 1 effect, treatment. Is it clear? Who asked that question? Is it clear? පැහැදිලිද? මුලංගිජා? You have to respond. The person who asked the question, I didn't know who asked the question.
Yes, sir.
පැහැදිලිද?
Oh, sir, පැහැදිලි.
Right. So now you consider it as a single factor. So that means treatment, all these are treatments. Treatment 1, treatment 2, treatment 3, treatment 4. Right. Further,
So profile map.
profile map நாங்க காய்ச்சோம்.
Sir.
Mean value எடுத்து plot பண்ணுவோம். Ordinary mean value calculate பண்ணி, after calculating the mean value of each of these factors, then you plot it. You plot it.
Okay, sir.
You get the mean value for each of these. For variety 1, what is the mean value? For variety 2, what is the mean value? You can calculate by hand, no? And similarly, you get the mean value for spacing 1 and spacing 2. You can plot it. Right? Okay. And after plotting, you will have to express whether there is an interaction, whether there is a mild interaction, whether there is a severe interaction, whether there is no interaction, and so on. Right?
Okay.
Right. Yeah. Just let's say this is 2 factor. Let's move to the 3 factor case. If you have 3 factor case, we have already discussed that partially, not completely. If you have 3 factor in CRD, 3 factor in CRD, complete randomized design, how it look like, right? So you can write it as 3 factor model in CRD. Yeah. This is how we write it. So you see, mu ijkl. Now we have 4. I is actually 1 to A, factor A. J is from 1 to 3 up to factor B. K is from 1 to C, the 3rd factor, because we have 3 factors, A, B, C. Right? The last one is the replicate. You see, last one is the replicate. We have three factors, A, B, C, right? For example, A, we can have several levels. B, we can have several levels. And C, also we can have several levels. So that we could write it as that. So main effects and the interaction. So as you all know, if you have three factors, for example, we have, these are the main effects. We spoke about the interaction. How many interactions are there? How many interaction is there?
AB, AC, BC, and ABC. 4 interaction.
BC and ABC. So you see, we have three main effects. This is the ith level of factor A, effect of ith level of factor A. J, beta J mean it is the jth level of effect of jth level of factor B, effect of kth level of factor C, alpha, beta, gamma. Then we have two-way interactions, or we call it as two-factor interaction. You see, this is the AB combination, AC combination, and BC combination. So these are two-factor interactions, or two-way interaction. The last one is three-factor interaction or higher order interaction. That is how we write each and every component. The last one is random error. So this is CR. So block effect is not there. Block component is not there. All right. Any questions on this? Please write down. Please write down now. Please write down this whole model. This is the model. This is how we call it as model. Right. So this is the ANOVA table. Write down. We can ANOVA table. We can discuss in 1 minute. I will get some water. This is the summary ANOVA table for three-factor experiments, but it is not given in the notation. We will discuss in 1 minute. I'll get some more. Right. How can we write the notation? How can we write the notation? Anyone? Treatment component is there, not there, and total is also not there here. So how can we write treatment? What is the degrees of freedom, anyone, for the treatment? A, B, C minus 1 for the treatment. So what is the notation for treatment? Sum square, summation, Y, I j k dot square divided by r minus c. So what is the notation for sums of square of a? Anyone?
Summation of
Yeah.
I dot squared over a minus c.
3 dot, right? Square divided by
A.
illa. So the sums of
A
square.
minus 1. A minus.
Hmm?
A minus
BCR.
Yes. B, C, R. Right? Minus correction factor. Correction factor doesn't change. Right. What about B then? What about B? Summation y dot j dot square divided by a c r minus c. What about C then? Summation y dot k dot square divided by a b r minus correction factor. What about AB? Summation y I j dot square divided by CR minus correction factor. For AC, summation yi dot k dot square divided by BR minus C. BC, summation y dot j k dot square divided by a r minus c. The last one, ABC, summation y dot sorry, y j k dot, give me a second, square divided by r minus c minus sums of square of a minus sums of square of b minus sums of square of AC. We'll have to deduct AC, then AB, sums of square of AB minus sums of square of AC. Sorry. AB, AC, BC. Right? Any questions? Then the mean square is dividing by the degrees of freedom. Right. I am giving another homework. Right. I'm giving another homework. Prepare. I know. for following. First one is with notations. Huh? First one, 3 factorial in CRD. 3 factorial in RCBD. 4 factorial in CRD. 4 factorial in RCBD. This is just the common ANOVA. You'll have to prepare this as a homework. Maybe I might ask question from the homework next week. Huh? So you'll have to get prepared. You have the weekend, you can prepare. All right. Any questions on factorial? Any questions on factorial? So we'll have to give the models also. Huh? So I forgot to say that. Including model. Huh? So I have given the model for that already. So we'll have to give the model for the rest. Any questions? Any questions? I have, I don't want to start with a new topic. I have some Tanish Kumar.
Yes, sir.
The notations, CRD notations, calculations,
Sir.
RCBD, CRD. So before I speak about some notations in RCBD and CRD, can you ask any questions on related to factorial? Any questions related to factorial? For example, let's say, any questions on factorial? Piomi? Prashna Munari Tiyanawaද?
No, sir.
Okkama පැහැදිලිද?
ඔව් sir.
ඔක්කොම ජීර්ණ වුණානේ. හොඳයි. Arosha?
Yes, sir.
Understood everything?
Yes, sir.
No, yes, partially the?
Partially.
Partially, yeah. Right. Okay, so you'll have to do some exercise. The lecture itself, following lecture itself, because this is a new subject. Following lecture itself will not enough to competent enough to get yourself to understand. So that you'll have to do some exercise. Not physical exercise, I'm asking the exercise on statistics, right? Okay. Right, in CRD, usually we say treatment. I say treatment 1, treatment 2, treatment 3, treatment 4, right? So I have 3 replicate, R1, R2, R3, as an example. So depend on the model, let's say Yij is equal mu plus alpha I plus error term. So this is the, I mean, it is the treatment effect. Treatment effect. It is the CRD model. So by looking at the model only, we can decide what subscripts have been given. So here, I is the treatment. So that Y11 mean, or rather than Y11, when you say I and J, so this first digit indicating the treatment, second digit indicating the replicate. Right. In this example, you can swap, right? You can swap as you like. Maybe first digit maybe replicate, second digit treatment. That is also possible. But you'll have to define it. You'll have to do the calculation accordingly. Otherwise, you will be in trouble. So let's say the first observation is given as, you can have any value, but this is called as Y11. This is Y12, Y13, Y21, Y22, Y23, Y31, Y32, Y33. I have seen Sivamani Madam has explained up to a certain level, right? So this is just supplementary. Y41, Y42, Y43. So this is without the absolute values. Huh? I'm just giving some numbers, right? Right here, if you add across the replicate, this, if you add across the replicate, what is constant here? If you add this, 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 what is the constant digits?
1.
1 is a constant. So that we say as Y1 dot. We are adding across the replicate. So that is why we call it as Y1 dot. Similarly, if I add this value, what is that?
Y2 dot.
Yes, Y2 dot. Similarly, you can say Y3 dot, Y4 dot. Right? In a similar way, right? In CRD calculation, actually, we don't calculate across the treatment. But if it is a RCPD, this is coming as block 1. This is coming as block 2, for example. This is coming as block 3. So we need the column multiplication also, column addition also. So I'm adding here. How I can write this? Anyone?
Y dot 1.
Y dot 1, right? Why? Because the changing values or changing subscript will be given as dot. Y, similarly, this one, second one, Y dot 2, Y dot 3. Now tell me, what is Y1 dot bar? Looking at the above terminology, what is Y1 dot bar? What is that? How we can call this?
Mean of that column.
Yeah, partly right. Mean of that column. Which column? I have given the names.
Treatment 1.
Huh?
Block 1.
Nah, make a block 1 the balan.
Treatment 1.
Huh? Yes, treatment. First treatment. This is the mean of first treatment. Isn't it? Look at what is 1 dot is Y1 dot is the addition of all the values of first treatment, not the second treatment. So this is mean of first treatment. So how we can get that? Actually, this is equal y1 dot divided by what? How to get the mean of that? It is depend on how many values you are adding. How many values you are adding in general? Here 3, but in general, what is that?
Number of replicates.
Exactly, number of replicates. So this is same as that. Number of replicates. So similarly, you should know what is 2 dot bar, etc., etc. Right? Now, when you add y1 dot, right, plus y2 dot plus y3 dot plus y4 dot. Actually, can you remember when this y1 dot, y2 dot, these values can be plus minus? We don't know in general. So that how we can avoid subtraction? Yeah, we can square it. We can square it. So divided by r to get the average value. To get the average value. So this is what we have already written as y I dot square divided by r. In this case, we have 4 treatments, so that we have added. Similarly, if you have summation y dot j square divided by r. So what is that? So not divided by r, divided by treatment T. So here, look at the division factor is depend on how many dots you are having. So before squaring, how many observation we are adding? Before squaring, how many observation we are adding for y1 dot? It is equal to the number of replicate. So that is why we are dividing by r, number of replicate. Clear? Similarly, can somebody tell me how I can write the second one, this one? Y, in our example, y dot 1 square plus y dot 2 square plus y dot 3 square, whole thing divided by, before we squaring it up, how many observation we added together? Yeah? 4 observation. But in general, how we define it as? In this example, 4. In general, what is that 4? It's equal to number of treatments. So we divide by. Similarly, if you say y dot dot, so you are adding across all the treatment, across all the replicate. So this is y11 plus y12 plus y13 plus goes up to, what is the last one?
Y43.
43. Right? Okay. Now you see here, we say summation y dot dot square divided by TR. So how many observation we added before squaring it up? How many observations we added before squaring it up? In this case, 12. In this case, 12. But in generally, how we can find out? If you multiply number of treatment to number of replicate, we can find out. So that is why, if you take the y11 plus y12 up to plus y43, we square it up. So before squaring, how many observations we are adding? That is equal to t into r. Is it clear? So this is how the notation works, right? This is how notation works. This we can say actually y dot dot bar. I think already your madam has given the information about this. Right. Any clarification question that you need to ask? Yeah. Any clarification? So I don't want to go much deeper. So any clarification? So you can do the homework, and if you have any problem, you can discuss that later in the next class. So next week, morning and evening, every day we have classes, right? Right. Any questions? Any doubts? Any clarification? If not, I think we will stop. Do you have any questions? Everything is fine. Okay, good. So we will stop with this. And Tanis Kumar. Tanis Kumar?
Yes, sir.
Orka,
Yes, sir.
எல்லாத்தையும் அந்த சாஸ் பிரச்சனையும் அட்டன் பண்ணுங்க. அல்லது ஒரு ஆளுக்கு 2 பேருக்கு இல்லாட்டி பிரச்சனையா போயிடும். ஒரு ஆர்டேண்ட் இப்பவே கழிச்சு ஆளுக்காருக்கு என்ன பிரச்சனைன்னு கேட்டு வேர்டு மொபைல் சார்கிட்ட கழிச்சு கிரியா மண்டே இடையில இன்ஸ்டால் பண்ணிக்கொள்ளுங்க.
ஓம் சார் நான்
சில இன்ஸ்டால் பண்ணல. இது அந்த ஆன்லைன்ல தான் செய்யும்.
ஓம் சார் யூஸ்
ஒருக்கா பாருங்க. ரைட்? Okay then.
Thank you, sir. Thank you.
Okay. See you on Monday 8 at 8. Okay, bye.